Hello everyone. So in today's video we are going to evaluate the limit of some trigonometric functions. So here we have this function and we have to find its limit as the variable x approaches 0. If we substitute x is equal to 0 directly, in the denominator we will get cos 0 minus 1 and cos 0 is 1. So in the denominator we will get 1 minus 1, that is 0. So we cannot substitute limit directly into this function. So let us simplify this function and see if we can avoid 0 in the denominator. So this will be equal to limit x approaches 0. Instead of cos 2x, I can use the formula 2 cos square x minus 1. So 2 cos square x minus 1 as it is divided by cos x minus 1. So now this can be written as limit x approaches 0. 2 cos square x minus 1 will be minus 2, and we can factor out 2 from both the terms in the numerator. So this will be equal to 2 into cos square x minus 1 whole divided by cos x minus 1. Now cos square x minus 1, we can write 1 as 1 square. So this is of the form a square minus b square. And the factors of a square minus b square are a plus b into a minus b. So this will be equal to limit x approaches 0 to factors of cos square x minus 1 square would be cos x minus 1 into cos x plus 1 whole divided by cos x minus 1. Now you can see that we can cancel out the factor cos x minus 1 from the numerator and from the denominator, and also we can take this constant 2 outside the limit. So this is 2 times limit x approaches 0 cos x plus 1. Now there is nothing in the denominator, so we can substitute limit as x approaches 0 directly into this function. So this will be equal to 2 and cos 0 is 1 and plus 1 as it is. So this is 2 times 2, that is 4. So the limit of our function as x approaches 0 is 4. Now let us take one more example. Let us take limit sin x minus cos x whole divided by x minus pi by 4 as x approaches pi by 4. Here also we can see that if we substitute x is equal to pi by 4 directly, the denominator gets 0. So we cannot substitute the limit directly. So let us simplify this. So this is limit x approaches pi by 4. We can multiply the numerator by square root 2 and also divide it by the square root 2. So this will be equal to square root 2 times sin x into 1 over square root 2 minus cos x into 1 over square root 2. We just multiplied numerator by square root 2 and also divide it by square root 2. And the denominator x minus pi by 4 as it is. So now this can be written as limit x approaches pi by 4. This square root 2 as it is. Sin x also as it is. Instead of 1 over square root 2, we can write cos pi by 4. Because cos pi by 4 is 1 over square root 2, and minus cos x as it is. Instead of 1 over square root 2, we can write sin pi by 4 and whole divided by x minus pi by 4 as it is. Now we can take this constant square root 2 outside of limit. So this is square root 2 times limit x approaches pi by 4. Now this is the formula of sin a minus b. Okay, So instead of the numerator, we can write sine x minus pi by 4 whole divided by x minus pi by 4. Okay, we used this formula here. Sine A minus B is equal to sine A cos B minus cos A sine B. Okay, so this is equal to square root 2. Now we know that limit of sine theta over theta as theta approaches 0 is 1. Now but here x is approaching pi by 4. So if we subtract pi by 4 from both the sides, x minus pi by 4 will approach 0. Okay, so now we have square root 2, limit x minus pi by 4 approaches 0, sine x minus pi by 4 divided by x minus pi by 4. So now we can use the formula limit of sine theta over theta as theta approaches 0 is equal to 1. So this will be equal to square root 2 times 1, which is also square root 2. Now let us take one more example. Let me write the function here. We want to find limit x approaches 0, sine 2x plus 3x divided by 3x plus one moment, this is 2x not 3x, 2x plus tan 3x. Now here also if we substitute x is equal to 0 directly, we will get 0 in the denominator, so we cannot substitute limit directly. Okay, so let us simplify this function. So here we can see that angle of sine is 2x. So if we get 2x in the denominator of sine, we can use the formula sine theta over theta as theta approaches 0 is equal to 1. So let us divide the numerator by 2x and multiply by 2x. So this will be equal to limit x approaches 0 sine 2x plus 3x whole divided by 2x, and let us multiply the whole numerator by 2x. Same way, the angle of tan is 3x. So if we divide a whole expression by 3x, we can get tan 3x divided by 3x. So we can use the formula tan theta over theta as theta approaches 0 is equal to 1. So let us divide numerator by 3x and multiply it also by 3x. So in the numerator we will have 2x plus tan 3x whole divided by 3x, and let us multiply it by 3x. Now let us write the denominator separately for both the terms. So in the numerator we will have sine 2x divided by 2x plus 3x over 2x multiplied by 2x as it is, and also write the denominator separately for the 2x plus tan 3x. So in the denominator we will get 2x divided by 3x plus tan 3x divided by 3x into 3x as it is. Now you can see that in the numerator we can cancel out this x from the numerator and denominator. In denominator also we can cancel out this x, and here 2x divided by 3x in that also we can cancel out this x. So now we have 2 over 3. We can take it outside of the limit. So we will have 2 over 3, and also let us write the limit separately for both the terms. So this is equal to limit x approaches 0 sine 2x over 2x plus limit x approaches 0 3 over 2 whole divided by limit x approaches 0 2 over 3 plus limit x approaches 0 tan 3x over 3x. Now we have the formula limit sine theta over theta as theta approaches 0. So we can write 2 over 3 as it is, and in the numerator limit sine 2x over 2x as x approaches 0 we can write 1 plus limit of constant will be constant itself, that is 3 over 2 itself. In the denominator limit of 2 over 3 will be 2 over 3, and also we know that limit of tan theta over theta as theta approaches 0 is 1. So now let us simplify this. So this is 2 over 3 so this is 2 over 3 into bracket 2 times 1 is 2 and 2 plus 3 is 5. So this is 5 over 2 whole divided by 3 times 1 is 3 and 3 plus 2 is 5. So 5 over 3. So now let us write 2 over 3 as it is times 5 over 2 as it is, and instead of this division we are going to write the multiplication. Since we have written multiplication, the fraction in the denominator will flip, so we have to write the reciprocal of 5 over 3. So it will be 3 over 5. Now here we can see that we can cancel out all the numbers. 2 gets cancels, 3 also gets cancels, and 5 also gets cancels. So our answer is 1. Hope this will help you to evaluate the limit of the trigonometric functions.